Hi guys, it's the Sciencebarbie. Today we're going to learn about Gaussian elimination. So Gaussian elimination is used to solve a system of linear equations like it's given here. Here we have three linear equations. We can see that the variables x, y, and z, they are not to the power of 2. There are no square roots or anything like that. So it's a linear system of three equations in three different variables. And the algorithm that we're going to learn today, it's called Gaussian, from the mathematician Gaussian elimination. Just have to pay attention to the screen. Okay, it's Gaussian elimination. And how are we going to write that down? So we start with the so-called augmented matrix. This is also a term we should remember. It's called augmented matrix. It's a way of writing down this system of linear equations. Now what we do here, we have the variables x, y, and z. And what we do is we write down the coefficients of these variables. So for x here in the first line, it's -1. It's 1 for y and 1 for z. And then here we have the right column here. That's going to be our solution. Let's call it S. Now the second equation, here we have 1 minus 3 minus 2 and 5. And finally, we have 5, 1, 4, and 3. And that's what we call an augmented matrix. We have here the coefficients of the variables in the system of linear equations, and here we are in the end going to find our solution. Now what we want to do is we want to find the echelon form of this matrix here, or the identity matrix, that we have the entries in the main diagonal. They should only be 1, and above and below all other entries should be 0. Now this is what we're going to do. How are we going to do this? In the first step, and we denote this here with an arrow, and we are going to swap line 1 and line 2. Why? Because we want here a 1 on the first position. Now again, it's x, so we're going to x, maybe a little bit smaller, we don't need that much space, y and z. Let's start here. It's 1 minus 3 minus 2, and we got the solution here, it's 5. And then we wrote down the first line, 1, 0, and the third line remained unchanged. Now again, what we already have here now is the pivot element. Here we have the 1 here, and what we want is we want to get zeros below. How do we reach this? Again, we make here this snake-like arrow. What we do is we add the first line to the second line. So the second line, we add the first line, and the third line, we subtract 5 times the first line. Okay, then we get a new system. Just make sure you can see everything here. Okay, we still have x, y, z, and the solution. Now the first line remains untouched. It's 1 minus 3 minus 2 and 5. Now the second line plus the first line, minus 2 plus 1 is 0. 1 minus 3 is minus 2. 1 minus 2 is minus 1, because we just added up. And 0 plus 5 is 5. And the third line minus 5 times the first line. 5 minus 5 is 0. Then we have here minus 5. Minus and minus is plus. It's plus 15. 1 plus 15 is 16. And here minus and minus is plus. Minus 2 times minus 5 is plus 10. 4 plus 10 is 14. And here we have 3 minus 5 times 5 is 25. 3 minus 25 is minus 22. Wonderful. Now the next thing we're going to do is we want to have here the number 1. We already have here 1. Now we want to have it here. How are we going to reach that? We divide by minus 2. So the second line is divided by minus 2. Okay. Then let's start again here. We have x, y, z, and at some point we're going to have the solution. The first line remains untouched. It's 1 minus 3 minus 2 and 5. Here the 0 is not going to change. Minus 2 divided by minus 2 is 1. Minus 1 divided by minus 2 is 0.5. And 5 divided by minus 2 is minus 2.5. And finally the last row, we just write it down. Or what we can already do with the third row, what we want to have here is a 0, because this is going to change to a 1. We already have that here, and here we want to have a 0. So we could either say it's going to be two ways. Either we say, okay, it's 16 minus 16 times the 1 here, or we use the old 2. So we can also use the old line 2 here. And we say, okay, if we multiply the second line by 8, we got minus 16, and we add it up here, we get 0 here, and that's what we want. So in this case, we say we take the third line minus or plus, because it's already minus here, 8 times the second line. Now what do we get? 0 plus 0 is 0. We get a 0 here anyways. We see 8 times minus 2 is minus 16. 16 plus minus 16 is 0. 8 times minus 1 is minus 8. 14 minus 8 is 6. And here we get 8 times 5. You can't see that? Now you can see. 8 times 5 is 40. 40 minus 22 is 18. Now it looks already quite nice. That's our augmented matrix now. At that time, I think we could already solve. It's not that hard, okay? Because we see here, 6 times z is 18. Can you see that? So we can write it down from the third line here. 6 times z, because that's the variable, is 18. If I divide by 6 on both sides, I get z equals 3. And that's already my first solution of this system of equations. Now I can use it in the second line here. So we're going to use it in the second line. We have 1 times y plus 0.5 0.5 times 3 equals minus 2.5. Now we got it here. Y, we have here 0.5 times 3, 0.5 times 3 is 1.5, and we bring it to the other side by minus, so we have minus 2.5 minus 1.5 is minus 4. Got the second solution. Y is minus 4. It's nice, isn't it? And now we go to the first line here. The first one, the first equation. 1 times x is x. Minus 3 times y, minus 4. Minus 2 times z, and z is 3, equals 5. Now let's have a look. Minus times minus is plus. 3 times 4 is 12. Minus 2 times 3 is 6, equals 5. 12 minus 6 is 6. And 5 minus 6, because I want the 6 on the other side, means x equals minus 1. Because here we have 6 and 5 minus 6 is minus 1. Now we have the three solutions here. Again, x equals minus 1, y equals minus 4, and z equals 3. And this is the solution to this set of linear equations that we started with. We used Gaussian elimination on the augmented matrix. And this is the solution that we got, and I hope that you liked the video.
Das war ein Mathematik-Tutorial der Sciencebarbie. Jedes Like und Abo des Kanals freut uns sehr. Für Feedback und Kommentar nutzen Sie die Kommentarfunktion.